Hello everybody. So today I will talk about calculus. The topic today is about find the value of x to make sure that this series is about convergence. So now I will show you how to answer. So we need to find about the interval and the radius of convergence. Now, about the first one, we know that we can use about root test. So I will put about an equals to this one in here. So we need to use about the limit and n approach to positive infinity, and we have n root. We put inside an in here. So because this one always provide a positive number because we have the absolute value. So for this one in here, they will got about the positive number. So I will put about 3 to the power of 2 plus n. 1 over number 3 to the power of 2 plus n. We put in here. And now we put this one inside the absolute value in here. With the n root, we can simplify like this. Two plus n divided by n, you got about 3 to the power of 2 over n plus 1. This one you got about 4x minus 12. Because n divided by n, we cancel about the root. And the last one, we have this one. Because n squared they provide a positive number, so we need to cancel about the absolute value. So I will consider about the limit in here. This one I can write into n squared plus 1 to the power of 1 over n. So I can write like this. So we know that we can put inside this formula. We have the formula that's about e to the power of ln of the e to the power of ln a equals to a. So this one is about capital A. We need to transform this one into this one. And then we need to put the limit go in here. And now we have the formula that's about ln a to the power of b equals to b lna. So we put this one go in here. So we got only this limit n approach to positive infinity. You got about negative 1 over n ln of n squared plus 1. So this one we can simplify like this. Now, if we look carefully about this one, when n approach to positive infinity, this one go to positive infinity in here. Ln of positive infinity, you got about positive infinity. This one they go to positive infinity. So that means we have infinity over infinity. So we can use about L hospital. So we do first the derivative on numerator. And denominator. So for this one, you got about n over n squared plus 1 after we do first the derivative of this one in here. First derivative of n, you got about 1. Now we can simplify and we just write like this. Now we divide by n squared on numerator and denominator. So when n approach to positive infinity, this one you got about 0, this one you got about 0. So that means this one equal to number 0. Now that means this one in here equals to number 0, and this one you got about number 1. So that means the limit of this one in here equals to number 1. So n approach to positive infinity 2 to the power of n, you got about 0 in here. Now if we simplify everything, you just got only 4x minus 12 over 3. And we need to know that this one should belong from negative number 1 to positive number 1, because after we destroy about the absolute outside, the value of this one should be smaller than number 1. That's why we have negative number 1 to positive number 1. Now we need to find about these intervals in here. So for this one, we multiply both sides by number 3. And later that we put this one go to the left and go to the right. This one you got about number 9. This one you got about 15. Later that we divide both sides by number 4. So the interval in here, that should be about from 9 over 4 to 15 over 4. The radius, that should be about 15 over 4 minus about 9 over 4. We divide by 2. So we calculate about this one, and we got about 3 over 4. And this is the answer for the question number 1. Now, let's go to the next one. We do the same technique. Now we put inside about the limit. So we will have about and root we put in here. Now we cancel about n, so they should be like this. So this one you got about n to the power of 2n divided by n, you got about n. This one you got about 1 over n. This one you got about 4 to the power of 3. This one you got about 2s plus 17. We know that when n approaches to numbers infinity, you got about 0 in here. So you got about n to the power of n. And we know that for this one in here, you will have about positive infinity because they go up. This one go up, that's why you got about positive infinity. To make about the convergence in here, only 2s plus 17 equal to number 0 because number 0 is smaller than number 1 and greater than negative number 1 in here. That's why you have only this one. So we calculate about s, and you got about negative number 17 over 2. So about the interval, we just have only one number in here. About the radius, that is equal to number 0 because we just have only one point, so we have number 0 for radius. Now let's go to the next one. For this one, I will use about ratio test. So I will put about an equals to this one. And then we have an plus 1 equal to n plus 1 over 2 multiplied by n plus 1 and we have factorial in here. So multiplied by s minus 2 to the power of n plus 1. So we have n plus 2 in here. So this one we need to expand, and you got about 2 with n, you got about 2n. 2 with 1, you got about 2. 2 plus 1 is about 3. Factorial. Multiplied by s minus 2 to the power of n plus 1. Now we have the limit n approach to positive infinity. So we have the absolute value, that's about an plus 1 over an. So we put this one going here and this one going here. Now we need to simplify. We know that 2n plus 3 factorial we can put into 2n plus 1 factorial in here. Multiply by 2n plus 2 and 2n plus 3. This one we keep the same. So n plus 2 we keep the same. This one we can put into s minus 2 to the power of n with s minus 2. This one we have s minus 2 to the power of n. Now we need to simplify this one with this one with this one, and now we just have this one left. Now if we look carefully about this one, we see that we have 3 factors contained by n, but we have only 1 factor contained by n in here. So that means this one is always smaller than this one in here. So when n approaches to positive infinity, this one you got about 0, and 0 is smaller than number 1. So that means s should belong on the value in here. So I will put about real number. So the interval that should be like this. And radius that should be about infinity. And this is the answer for question number 3. Now let's go to the next one. I will use about root test, and I will put an equals to this one in here. So we put inside the limit, and n approach to positive infinity, and we have n root, and we have an. So we put this one go in here, and now we need to simplify. We know that all the number in here they are positive, so when we cancel by n root, they will got like this. That is about 4 to the power of 1 over n plus 2 over 5 to the power of 1 plus 1 over n. And this one you got about s plus 3. So this one you got about 0 when n approach to positive infinity. So we have 4 to the power of 2 over 5 s plus 3. And we know that this one should belong from negative number 1 to positive number 1. So we divide both sides by 4 squared over 5. So 4 square is about 16. You got about 5 over 16. Similar for this one. Now I will put number 3 go to the left and go to the right. We calculate about this one. You got about negative 53 over 16. This one we have negative 43 over 16. So this one, the interval of convergence, that should be about from negative 53 over 16 and negative 43 over 16, the radius of convergence. So we have about negative 43 over 16 minus negative of number 53 over 16. We divide by 2. So you got 5 over 16. And this is the final answer. Now let's go to the last one. We use about root test. So I will put an equals to this one. Now we use the same formula for question number 4. So if we simplify, you got like this. We find the limit of this one, so we apply the same formula of the beginning. We just do on this question in here. So this one you got about number 1 when n approach to positive infinity. So if we simplify, you got like this. This one you got about 0, and this one shoots between from negative number 1 to positive number 1. So we divide both sides by 6. Later that we put negative number 1 go to the left and go to the right. And then we divide both sides by number 4. So we got 5 over 24. And this one we got about 7 over 24. Now we go back to this one. We have 6 to the power of n over n. In case they create about negative number 6. If this one is about negative number 6, you got about 6 to the power of n over n, and we have negative number 6. Negative number 6 to the power of n minus 1. you can get about negative in here. That's about negative number 1. So I will put negative number 1 in here, and you got about n minus 1. 6 with 6n, and we have negative number 1. You got about 6 to n minus 1 over n. So this one you got divergent. Now let's go to this one. We have negative 1 over 6 in here. When for s minus 1 they reach about negative 1 over 6. So this one we transform into negative 1 over 6. And now we will have about 6 to the power of n over n. And we have 1 over 6 to the power of n minus 1. If we simplify, and you got like this. Number 6 to the power of negative number 1, you got about 6 in here. And I will put negative number 1 go in here. And I will put negative number 1 to the power of n minus 1 in here. So this one they cancel, and you got about negative number 1 to the power of n minus 1. And we have 6 over n. With this one like this, you got about convergence. When we do with negative number 1 with the power in here. But if this one is about positive, you don't have this one. However, you just create about harmonic series. Harmonic series is about divergence. So we don't have the positive 1 over 6. So after we analyze everything in here, we need to accept about s equal to 5 over 24. So the interval in here, that should be like this. And radius, that should be about 7 over 24 minus 5 over 24 divided by 2. You got about 1 over 24. But this is harmonic, not harmonic series. And that's it, the answer, everything in here. This is the end. Thank you for watching.